So let's just see how this works together. So this is the picture we had earlier. We've got a car with a large number of processes, and then we have some back-end processes, front and back, and then so what we do is we have an SDP client in the vehicle, and we also have an SDP gateway. And think of the SDP gateway as your dynamically provisioned VPN firewall gateway and NAT. And then we have an SDP controller. So the first thing that happens is when the vehicle powers up, it sets up a secure channel, a mutual TLS-based, certificate-based channel between the vehicle and the controller. At that point, we run two sets of back-end processes. First, we do hardware identity verification. So that is, we match the hardware systems inside the vehicle to the digital certificate given. And we do that through the SDP control channel. We can also do things such as inventory management. The cars are so complex now that there is a requirement to do constant inventory of what's in there. The next thing, even more important than hardware, or once we've done hardware, is software attestation. So this is where we can remotely scan for what are the active software processes running, number one. The other thing we can do is we can do hash verification. So because we know the hashes of the software that went into the vehicle, we can now check the hashes to see if they've been tampered. And we'd probably be communicating with the cryptographic components of the cars themselves. So this is probably for another show, but the good thing is the chips, whether it's from Intel or Qualcomm, have a lot of native cryptographic functions that allow us to basically do the hash and make sure the hashes aren't tampered. So once the hardware identity has been verified and the software's been checked, then we go to the next step, which is look at the service plan. What has the user purchased, the driver, what packages has the OEM turned on. And then we look at those entitlements, and then we basically set up a secure data channel from the SDP client to the SDP gateway for the processes. Now, in this slide, if you're looking at the slide, I've set up one connection. But the beauty of SDP is really that we can set up an arbitrary set of connections. The great thing about SDP is it is a software construct. Right. So we can set up one connection, we can set up 10, we can set up 100. It really doesn't matter because we're using the control channel to basically say, well, hey, use software process, you've been authorized and authenticated to connect to this cloud process, and let me basically set that up for you. So it's a very elegant and scalable model. So the other thing I want to stress is, in the slide I just showed one SDP controller. The SDP controllers themselves are stateless entities. So you can have 20 SDP controllers, you can have 100 SDP controllers. So you could imagine 1 million cars connecting to controllers around the world. Then from there connecting to back-end identity and attestation systems, connecting to federated identity systems, and then basically these networks being provisioned. So it's a very scalable, elegant model. So the great thing about the secure enclave idea and using SDP as the architecture to implement it is it really allows us to do, I think what you talked about in your first webinar, is really a secure closed loop architecture, which is really where the automotive industry is going. They basically want to leverage the internet for connectivity. They want to leverage all of the great software in public clouds, but they need it to be partitioned from the broader internet, right? From a security perspective, a privacy perspective, a monetization perspective. So using SDP as a way to create secure enclaves really allows us to do this at tremendous scale. So that's very nice.